Cars that we drive, believe it or not, in the factory line, there is somebody with a tone generator on the inside of the car and somebody walking around, or a fixed area outside that's measuring to say, are there any leaks in that windshield? You know, cars are not cheap. And if I'm going to buy a car and I'm driving at 50 miles an hour and I'm starting to hear whistling and all that kind of stuff, I get a little annoyed, almost as annoyed as hearing my phone. So what the companies have figured out is it's not really expensive technology to go ahead and put a tone generator in there and listen to ultrasonic frequencies. You know, let's go ahead and do it. For us, man, it's certainly not as expensive as the audio gauge equipment that I use. It's certainly not as expensive as the infrared equipment that I use, but it has great value to a client where you can say, man, that bulkhead is not watertight, or there are leaks around windows, and you look at the gasket and you tell the guy, man, it needs to be replaced, and it's sort of like, yeah, one of these days I'll make it around to it. But if you can have him there and give him the experience of hearing the sound of that tone generator and leaking around a window or a fixed window and stuff like that, an epiphany occurs, you know, something that is more or less, oh my God, I do understand. Maybe I need to do something about this. All right, so again, a little bit of theory, discussion. We've already been this. If you ask questions, just tell people who you are. And again, we'll try and do some demonstration during the 10-minute break. The UltraProbe 2000 is what I'm going to be talking to you about today. It's not the most expensive piece of equipment out there. In fact, it's probably the minimum amount of equipment out there by UE Systems. UE Systems is a great company. I did my level 1 training with them so that I understood that there's a lot of different things to use ultrasound for. Those of you that might be looking at machinery and you're using stethoscopes or that screwdriver next to your ear, you can use this kind of product and it works really well. So this is the UltraProbe 2000, what it looks like. And I did a little bit of a demonstration for you for the sensitivity of the product. You could hear my fingers moving back and forth as I So again, when you download the PDF file, it's going to take you to that link so that you can learn more about the products that they have out there. Airborne Ultrasound, its concepts, we'll talk about some definitions and some applications. So, some technical stuff or not so technical stuff from physics way a long time ago. Work is defined as the amount of force that's required to displace an object. Mechanical efficiency is, you know, how much energy does it take versus the amount of energy that you get out of applying to something. Friction is the largest factor contributing to energy loss. Okay, makes sense. Guess what? Friction generates ultrasound. I'm going to take you to a website in a few minutes where you hear different sound frequencies of what things sound like when they're going bad. But right now we're just going to go through a few things. So mechanical and rotating machinery, the website that you'll go to or you'll be able to see is what does a bearing sound like when it's good? What does a bearing sound like when it's bad, kind of stuff. The next thing is, we talked about that just a few seconds ago, this concept of using a stethoscope. On this equipment here, there's a little probe that you can put on the end of it and actually touch pieces of machinery. It's no longer airborne anymore, it's now contact. And you're listening for that ultrasound frequency coming in and determining whether there's something wrong. You can always compare it to something that seems to be working fine. We'll talk about that in a minute in terms of the sensitivity of the things leading to a failure. There's the concept of a bearing that's spalling versus a good bearing. Gears and friction and lack of lubrication. There's another thing that they use in the commercial industry where they actually have an ultrasound that's hooked up to a grease gun. And they'll listen as things are moving inside. And it's sort of like, how much grease do I need to add? Well, when the sound goes away, I don't need to add any more lubricant there. Add too much lubricant, as we all know, you overfill engines and stuff like that with oil, you cause all sorts of problems. Same thing in commercial industry. They're trying to figure out, let's just add enough and not more than what's needed to cause a problem. The methodologies, sensitivity to detecting stages leading to failure. So this is something that I learned when I took that level 1 course about ultrasound. You can isolate the signal on machinery when you're using the ultrasound with that stethoscope, say, for example. The next thing after that, believe it or not, is infrared, because usually friction is going to generate a little bit of heat, and depending upon how sensitive your imager is, you may pick it or you may not pick it up. But what I'm telling you that is, in these different types of NDT methods, in this particular case, ultrasound is the most sensitive, followed by friction and picking up with the infrared camera. And the next thing is, you know, you're running oil analysis. Most of us, as a courtesy, or maybe as a little bit of a profit margin, are taking oil samples when we're looking at machinery and gears, when we're doing pre-purchase surveys or something along those lines. I think a lot of us sit there and say, look, the man just went ahead and changed all the fluids out. There's no way in the world I'm going to find anything. But if you need a baseline, we'll be happy to go ahead and do the sample. So again, ultrasound, infrared, lubricant, oil analysis, vibration analysis. Vibration analysis is big in the commercial industries. You go into factory plants and they have rotating machinery and bearings and all sorts of stuff. Vibration analysis is another one of non-destructive technologies that they use. They're typically doing that ultrasound and the infrared and the lubricant and vibration, trying to figure out when something is going to possibly fail so they can schedule a planned maintenance cycle instead of running something to complete failure and lots of money being lost while something is down. And then, of course, the last thing is failure. Burns up, blows up, whatever. An electrical system, guess what? You can also use the airborne sound to go ahead and listen for arcing and coronas and stuff like that. So you're working on a ship, you know, that may have, 480 volts going on in there, and you're going to have a mate next to you opening up a cabinet if you're going to do infrared kind of work. Yeah, I would be using my probe to go ahead and listen for arcs and tracking and corona before I said, let's take a look inside there, because if I can hear a problem already, it's going to say, I know that there's a problem here, guys, let's go ahead and make sure it's de-energized or something along those lines before you start opening it up. So here is a good example. Spot to go ahead and go to these pictures. So we're back at the UE Systems website. They have a great little recording library out there for different sounds that you can hear. What I'm going to go ahead and do is take a look at a slow speed faulty bearing. I'm going to click on the sound here. Again, this is something that you may not hear with your ear, but when you use the stethoscope attachment to the airborne ultrasound, you can hear it. And it really doesn't take a rocket scientist to say, I don't think that sounds right. There must be something wrong. We need to take a look at things. Let's go back and look at the coronas and tracking just so that you hear something with electrical systems. So here they're shooting an area where there's high voltage coming into an isolator. He's using some really cool equipment here. It's like a parabolic focusing dish, standing on the ground and, shooting a high power transmission line coming through. You can hear that popping in the background. So that's another example of some of the different technologies that you can use airborne technology for ultrasound. For us, simple and dirty. Tone generator, leak, no leak kind of stuff. And you heard me do the leak just a few minutes ago where I turned on the generator and you can hear a warbling sound. Well, guess what? You can also hear it with vacuum lines and pressurized gas lines. Where could you use it on a boat? Wet exhaust system. You know, fire it up and you're doing that probe looking around, okay? Man, I hear something that just doesn't sound right. And you get to that area and it's sort of like, of course, the hose clamp is broken. Or the fiberglass, extrusion tube is split. You don't always, it gets you to the problem faster, let's put it that way. Here's another trick out there. It's called liquid leak amplifier. Basically, if you had a very, very slow pressurized leak and you didn't generate enough vibration to hear it immediately with that airborne focusing probe, you put a little bit of liquid in it and it will go ahead and pop. Every once in a while you hear a pop, pop, pop. So it's a very slow process, but it's another way to see if there's a problem with a leak. So maybe you were looking at, oh, who knows, maybe an aluminum fuel tank, and they're doing a 3 psi tank on it, pressure test on it, and you're checking around welds and stuff like that. Probably could use this technology, put a little bit of liquid leak amplifier on it, and listen. I did a tank not too long ago, an aluminum tank, that actually it was drained and we were looking for leaks, so I put that tone generator inside and I went around the outside of it and it's sort of like I could find the leak. Once I found the leak, sure, it was obvious that's where the problem was, but the ability to get there quickly by using that technology was great. So watertight compartments and hatches, portholes, and doors. So you're looking at commercial ships, and they're trying to figure out that hatch needs to be watertight. Well, is it watertight? Put that tone generator on the other side and go around it. So the theory: sounds produced by an object that has some kind of vibration property. Makes sense. My fingers had vibration property when I was rubbing them back and forth and I had created some friction. Sound will travel through different mediums at different rates. It's going to go through a solid, a liquid, and gas, but guess what? It's not going to go through a vacuum. So if you're expecting to hear a sound in vacuum, you ain't going to hear it. Makes sense. Human hearing frequency. Okay, here's a little bit of trivia. We hear anywhere between 20 hertz and 20 kilohertz. If we're lucky, when we get a little older, we still can hear up to 16.5 kilohertz. What I want to let you know is that on some of these technologies on certification, you do have to have visual, exam. In this particular case for ultrasound, you do have to go to somebody to measure your hearing because you're doing a lot of your stuff based upon what you hear. So if you can't hear, then this is not really going to be the technology for you, per se. I say per se because they do have some really fancy probes out there that generate sine waves. And you can go ahead and take a snapshot of the different sine waves and say, look, that's different than this one over here, there's a problem. Ultrasound frequency above 20 kilohertz, that's what I was trying to tell you. This machine here has got something known as heterodyning. Fancy word, but basically what it's saying is it takes that high frequency that we can't hear and it lowers it to a frequency that we can hear. That's how you could hear my fingers going like this. Some general points on using this airborne ultrasound. You can have competing sound from different backgrounds. You're working in an engine compartment and you got a vibration over here, but man, there's a vibration over here and it happens to be coming off a wall. So there's a technique that you learn that's called gross to fine, where you go ahead and start, just kind of like if you're doing forensic photography, you stand back and look at something and you slowly focus in until you find the problem. Same thing with the ultrasound technology. Stand back, listen for stuff, attenuate it, make it a little bit lower, keep going in, and as you go down in the responsiveness or the volume of finding things, you finally will find that area where there's a problem occurring, and then you might put on a little probe that has a small diameter hole, and you actually put it right on top of where the problem is. So sound reflections, just like in infrared thermography, you've got reflections from background. Kind of makes sense. because we're not looking at electromagnetic, radiation coming out with photons and all that kind of stuff that you're looking at infrared, but it still is a waveform. It still is a waveform that hits that wall and comes back. So I may hear something here that occurred back there because it hit the wall and bounced back to me. So I'm zeroing in on where the problem is. That grows to fine. That's what I was talking about. Step back and slowly move into where you find the problem. I think we'll go ahead and push on if it's all right with you. It's 11:20 or so. I'm going to go ahead and stop around noon. And I think the next thing what I'd like to do is just go right on to going the wrong way. Let's go back right on to infrared, unless somebody would like to take a break. Good, we'll go on to infrared. So let's talk a little bit about theory, discussion, same kind of stuff. If you have questions, let other people know who you are, what you're doing. We'll take that 10-minute break, and it'll be right around lunchtime, depending upon how long you want to listen or ask questions and stuff like that. I'm available all during lunch. It's just up to you. FLIR. Okay, I'm not selling FLIR, but I will tell you a few things about FLIR. I started using their equipment back in 2002. I live in a Navy town. I live in Jacksonville, Florida. People in the Navy, man, they know about FLIR. People in law enforcement, they know about FLIR. The last thing I need to do when I'm out in the field charging big bucks because I'm looking at composite materials is to have to go ahead and justify the equipment that I'm using. There's no reason why I couldn't be using Fluke or anything else that's out there, but half the job is building confidence in your client to hire you. If you say, in this case for me, I use FLIR equipment, oh yeah, I knew that. I use that stuff in the Navy. Cool, go ahead and do your work. Again, another link to FLIR. And I responded to something out on Boat Pokers the other day. Most of us are familiar with Raymarine. Well, Raymarine got bought out by FLIR probably within the last year. So what I'm saying is that FLIR certainly is dedicated to doing military, it's certainly dedicated to doing law enforcement, but when they go ahead and buy Raymarine, it's sort of like, I think that they're planning on doing some cool stuff in the area that's going to be affecting us in the marine industry. So, magically we go out to the FLIR website, and I should be bringing up the T-Series camera. Now, I brought the newest T-Series camera with me to show you guys. I still use the P65. There's a reason for that, because it does burst recording. The P65 does burst recording. I'll talk to you about that a little bit later. I'll show you a demonstration of what's going on. I like the T65, and I can't wait for them to come out with burst recording on that. Burst recording is like a video, but the thing about the video is every image that's saved can be manipulated and looked at and investigated. With the other cameras that are out there that don't have burst recording, you're like Ansel Adams waiting for the best canyon shot with the sun coming up or sun coming down. Did you get it in focus so that you can work with it later? The other thing is that they talk to you about, the selling people of cameras will say, oh, you need this resolution and you need this kind of lens, and you can use this lens and only take one shot versus the other lens where you would have to take 4 shots to get that same image. Well, burst recording, man, I can just scan the entire side of the boat in a minute. I don't have to get all those different lenses and stuff like that. So that's why I'm a very big proponent on this burst recording. I'll also show you a little bit later how to go ahead and get a copy of the standard that I co-authored on how to look at fiberglass boats. It'll talk to you about lots of questions out there saying, what kind of resolution do I need? How do I do stuff? It's all answered in this, and quite frankly, when I'm doing a job, I'll go ahead and highlight the areas of this, and we'll sit down with the client ahead of time and have a meeting and it will go ahead and define his responsibilities for things that he needs to get for me or have set up for that boat in order for me to do my examination, as well as my deliverables back to him. It's a great working document. So that's the T65 from the FLIR website. Theory. I'm going to say that most objects radiate energy. When we took our level 1 courses, they said, man, everything radiates energy. It's not true. There are tricky things that you can do to make things not radiate energy. And there's a reason for that, because our military doesn't want to see certain signatures when they're out there. So they're not stupid. They figured out how to way to do it. So don't get trapped into, that thing. Everything does energy. No, not everything, but most things do. Radiant energy is described in photons and wavelengths. So this is the way that we're able to see things or sense that something's hot. We're sitting over here and we feel heat coming off something. It's the photons and the wavelengths that's coming off there. We see stuff and we are intent, based upon our experience, man, you don't touch something that's red hot. In fact, when you start working on boats, it's sort of like, maybe I'm not going to touch that engine part that paint can't seem to stick to it anymore. An epiphany of the obvious when you're going ahead and shooting it with an infrared camera, but you may not always understand it until you see it and all of a sudden the light bulb goes off. The old gasoline engines that use the cook stove is what people call it. And, it had a little place on the block that got really hot, and it went ahead and changed the metallic springs so the choke would open and close and stuff like that. It's a brilliant thing to see with an infrared camera. Don't touch that, it's hot, it's 300 degrees. Energy in the infrared wavelengths can be isolated, detected, and correlated to temperature. So that's why we are doing infrared cameras. That's why we're also doing this concept of, non-contact thermometer. Same technology, same wavelength and stuff like that. The difference is that this is telling me a analog temperature on here. When I first bought one of these, I had no concept of different emissivity of products. Something that's shiny metal, it might show me a different temperature than something that's flat temperature, painted flat white or black. I didn't know that when I touched this and I saw a little red dot over here, I thought I was measuring that dot. Hell no. Something called spot size. I may be measuring that damn wall. You see it with the camera, you don't know about it when you're using this. Most of the people who use this kind of stuff are smart. They know, I'm going to measure the engine temperature. I might go ahead and measure the oil filter, because that's usually something that I can get to very easily, and the fluids are running through the engine. And gee, engines are supposed to just run a little bit less than when they're going to fail, because we want to make sure that that temperature of the oil is at the right viscosity. Too cold, it's too viscous. There's going to be problems there. Too hot, it's not going to be viscous enough. So a mechanic who's doing engine surveys is going to be about 6 or 10 inches away from, and it doesn't matter. But people who are doing home inspections, building, and man, I'm going to shoot that corner 20 feet away from me. It's sort of like, no, there's a little bit of education that needs to occur there. So great technology, I won't discount it at all. It's just that sometimes an image is easier to show to a client and convince them what might be going on. Okay, so it's obviously going to provide surface temperatures, are going to provide useful information about the internals of the object. So when you're explaining infrared to people, man, it's like X-ray. Man, I can see through stuff that people are saying to you. And you listen to them and you smile and you knock their head, because nobody wants to be corrected all the time. But you just kind of say to them, when you're working with this document here that I'm suggesting you get a copy of, they're like, no, I'm just reading the surface. And if the surface is all boogered up, if it's got, critters growing on it, or you've got different types of paint in there and stuff like that, I'm going to be seeing a different emissivity coming off, which means I'm seeing a different temperature pattern. This document talks about something, and it's kind of interesting. I think it's something that I coined. It's called a positive finding, pertinent finding, versus a negative pertinent finding. So we're like, what the hell is he talking about? Negative pertinent finding. I'm looking at a fiberglass boat. It has a high shiny surface on it. I see something that looks funny. And as I look at it and walking down the boat, man, it's following me. It's my reflection coming off, okay? It's pertinent to what I'm looking at, but it's negative because it's not what I'm trying to find. A positive pertinent finding would be something in the lines of, yeah, it didn't change when I moved and did different viewpoints around the boat, when I took different perspectives from that gross area to the fine area. So again, keep in mind, you're only looking at the surface, but sometimes that surface pattern is giving you an idea of what's going on beneath. When I looked at that steel sailboat, you know, I wasn't really looking, you know, anything other than the surface, but because it was cooler inside, because water had accumulation, because corrosion was going on, I was able to see it as a surface pattern. I call it the epiphany of the obvious. These people that are selling cameras, they call it the wow effect. Because basically, you see an image and it makes sense to you all of a sudden. They've set the hook. They're ready to reel you in to buy that equipment. Epiphany of the obvious is sort of like, yeah, I knew that, but I didn't see it until I used the camera. And maybe I could have seen it a little bit later if I'd spent another 45 minutes looking through it. But most of us, when we're doing surveys, it's sort of like, yeah, well, you know, maybe you got a half an hour to work with if the guys are doing a really fast job on that short haul and they're cleaning the bottom, you know, and you're banging through the boat and doing your stuff, you know, and it gets to be about 3 o'clock and man, your client is fading fast and you sit there and say, why don't you go have a drink somewhere and come back and then I'll just debrief you, you know, versus them going, when are you done? When are you done? Are you done yet? Because they're going to be the first ones to come back and say you missed something later on. So a little bit of definition of epiphany. So it basically is telling me, at least the way it felt for me, is that it's a sudden realization or comprehension of the essence or meaning of something else. That's what this technology seems to bring to us because we can see it. I did a job once, and I'm sure everybody here has had people that don't like you picking through their boat. And you load up the entire electrical system and a breaker pops. So we're like, that's not right. Oh, it's been that way for the last 10 years, not a problem. Well, can we open up that compartment so I can take a look inside? Sure, open up the compartment and a warm blast of air comes out and hits me. That's not right. Oh, it's been that way for 10 years. Got out the thermal imaging camera and I started scanning and there was an area that was hotter than what it should be. I showed him the picture and all of a sudden he had that epiphany. Damn, that's dangerous. I've been living on borrowed time. Maybe I do need to get it fixed. I wouldn't want to sell that to somebody else and have them have a problem with it. So, let's talk a little bit about some terminology here. Again, this was taken from the standard. Radiometer. That's pretty simple. It's an instrument that's going to measure radiant energy coming off of something. We have that infrared spot radiometer, which we all call the non-contact thermometer. It's measuring a spot. It is displaying surface temperatures. Then we have an infrared imager. Okay. The imager is something that shows a temperature pattern. It only shows the pattern. It doesn't actually show you the temperature. So, for example, I can scan a boat, I can scan an electrical panel, and I do not display the temperature bar on the right-hand side showing me what the temperature is. All I know is, or I'm trying to convey to you, is that it's not a homogeneous pattern across there. There's something different. Okay? That is what's known as the imager. An imager radiometer, just like that non-contact thermometer over there, now I have an image. It's an imaging radiometer, and I'm actually tying temperature patterns to it. And an infrared thermographer obviously is a person, key element here, who's doing infrared inspections using an imaging radiometer. Not just an imager, but a radiometer that actually is telling them what the temperature could be. Because you may have a temperature criteria when you're looking at an electrical panel that's fully loaded, that says like, this wire over here is 25 degrees Fahrenheit hotter than the other one. There might be a problem there. You're doing it with your spot radiometer. Something wrong here. With the imager, you might know that all you have to do is, you see the temperature pattern and it's right at the base of the wire where it attaches to what's holding it, securing it. It may only be a half a turn on that terminal to go ahead and crimp it down tight enough so that there isn't any resistance there. You might see that the entire wire is hot, or you may see a section of the wire is hot. You may go into a boat like most of us do and it looks like a rat lived in there. You know, man, you just don't go home at night and you don't feel good about it. But what I'm telling you is if you load everything up and you look at it for the imaging radiometer and you don't see anything hot, it still needs to be fixed, but at least you are going home knowing that maybe it's not going to burn up today. General points on temperature detection, some competing factors. Obviously the reflections from the background, we talked about it with the sound. Different composition of surface materials. When you take that level 1 distance learning course, you know, very easy thing to take. It costs some money, but you can do it in the convenience of your own home and get a lot of information, not only about general things of thermography, not specific things that I'm talking about, things that will give you that information that you need. So the reflectivity, people who race engines, you know, they're going to paint the surface of them different colors for a different reason. Not necessarily because it's cool and fancy, but there's a reason for it. The distance to the object, you know, from here to there, do I expect to get a good temperature reading? Maybe if I'm using a really high-powered lens.